Dropping an anvil from the International Space Station, ISS, sounds like a classic cartoon prank, but in the realm of orbital mechanics, it is an exercise in extreme frustration and complex physics. You wouldn't just be dropping it, you'd be launching a multi-year project that would likely end in a fiery streak across the sky, nowhere near your target. 1. The drop is actually an orbit. The first mistake is thinking that dropping something from the ISS means it falls straight down. The ISS isn't just floating, it's screaming around the Earth at approximately 27,600 kilometers per hour, 17,150 miles per hour. When you let go of the anvil, it shares that exact same velocity. Instead of falling toward the target, the anvil would simply float alongside the ISS. To make it fall, you have to slow it down. You would need a rocket engine attached to the anvil to cancel out its orbital velocity. Without a massive deorbit burn, the anvil stays in space forever. 2. The atmospheric brick wall. Assuming you slowed the anvil down enough to enter the atmosphere, you now face the entry interface. Speed. The anvil hits the upper atmosphere at Mach 25. Heat. The air in front of the anvil can't move out of the way fast enough, so it compresses and turns into plasma. Temperatures reach over 1,600 degrees Celsius, 3,000 degrees Fahrenheit. Structural failure. Anvils are made of cast iron or forged steel. While tough, they aren't aerodynamic. The anvil would start to tumble violently. The extreme heat and mechanical stress would likely cause the anvil to melt or shatter long before it hit the precise target. 3. Precision is impossible. Even if the anvil survived the heat, perhaps you gave it a heat shield. Hitting a precise target is a mathematical nightmare. The Coriolis effect. Because the Earth is rotating beneath the anvil while it falls, its path would curve significantly. Variable winds. Jet streams and lower atmosphere winds would buffet the irregular shape of the anvil, pushing it kilometers off course. Terminal velocity. Once the anvil slows down in the thick lower air, it would reach a terminal velocity of roughly 300 to 500 kilometers per hour. It's no longer an orbital weapon. It's just a very heavy, very inaccurate piece of falling scrap metal. 4. The result. If you manage the impossible, slowing it down, shielding it from heat, and calculating the rotation, the anvil wouldn't leave a Looney Tunes crater. It would hit with the force of a small bomb, but the chances of it hitting your specific X mark are essentially 0. It would likely land in the ocean or a random forest hundreds of kilometers away.